Our planet is a place of breathtaking beauty and profound tranquility. We marvel at its serene oceans, its majestic mountains, and the gentle rhythm of its seasons. Yet beneath this calm lies immense and untamed energy. Earth is a dynamic system, constantly in motion. Its tectonic plates grind against each other, its oceans churn with powerful currents, and its atmosphere swirls with colossal weather systems. These forces shape continents and create climates over millions of years. This activity fosters life, but also brings destruction, reminding us of nature's power. What turns a natural event into a disaster? It's when nature's force collides with human vulnerability. A disaster happens where a natural hazard meets people and communities unprepared to cope. Strong buildings and planning can save lives, but poverty, poor construction, and lack of preparedness turn hazards into catastrophes. By reducing our vulnerabilities, we can face nature's fury and save lives. In our modern world, it's easy to forget that our lives depend on a fragile, dynamic planet. Understanding natural disasters isn't just academic, it's essential for survival and resilience. This knowledge empowers us to prepare, adapt, and protect our communities. As risks evolve with climate change, learning and action are more urgent than ever, so we can build a safer, more resilient future together. Our planet's surface may seem solid and unmoving, a permanent foundation beneath our feet. This perception, however, is an illusion. The Earth's outer layer, the lithosphere, is not a single solid shell. Instead, it is broken into a mosaic of enormous pieces known as tectonic plates. These plates are in a state of constant, slow-motion drift, floating upon the semi-molten mantle beneath them. They move at roughly the same speed your fingernails grow, pulling apart, colliding, or grinding past one another in a silent geological dance that spans eons. It is along the boundaries of these plates, known as fault lines, where the immense stresses of this planetary movement accumulate. For years or even centuries, the friction between plates can hold them locked in place, while the pressure builds relentlessly, year after year. An earthquake is the sudden, violent release of this accumulated strain. When the stress finally overcomes the friction holding the plates together, the rock fractures and the plates lurch into a new position in a matter of seconds. This abrupt movement sends out immense waves of energy, called seismic waves, that radiate through the Earth's crust in all directions, much like ripples spreading from a stone thrown into a pond. It is these waves that we experience on the surface as the shaking of the ground. The point underground where the rock first breaks is called the hypercenter, while the point directly above it on the surface is the epicenter, where the shaking is typically the most intense and the damage the most severe. The magnitude of an earthquake is a measure of the energy it releases. This is most commonly measured on the moment magnitude scale, which has replaced the more famous Richter scale. This scale is logarithmic, meaning that for each whole number you go up on the scale, the ground motion increases by a factor of 10, and the energy released increases by a factor of about 32. Therefore, a magnitude 7.0 earthquake releases over 30 times more energy than a magnitude 6.0, and nearly 1,000 times more than a magnitude 5.0. This explains why the difference between a moderate tremor and a truly catastrophic quake is so immense, capable of turning a city into a landscape of ruins in under a minute. The destructive power of an earthquake is not limited to the initial ground shaking. The primary seismic waves can trigger a cascade of secondary hazards. They can liquefy soil that was once solid, causing buildings to sink or topple over. They can sever gas lines, leading to devastating fires that rage through the rubble, often causing more damage than the quake itself. In mountainous regions, the violent shaking can dislodge vast quantities of rock and soil, triggering catastrophic landslides that bury entire communities. It is this combination of primary and secondary effects that makes major earthquakes one of the most formidable and terrifying geological disasters our planet can produce. a stark reminder of the restless power beneath our very feet. The destructive reach of a geological event is not always confined to the land. When a powerful earthquake or a violent volcanic eruption occurs beneath the ocean, it can displace a colossal volume of water with unimaginable force. This is the birth of a tsunami, a series of ocean waves that can traverse entire basins with terrifying speed and power. In the deep ocean, a tsunami is often barely perceptible, but as it approaches the shore, it transforms into a towering wall of water. The 2004 Indian Ocean tsunami serves as a devastating example, claiming nearly 230,000 lives across 14 countries. This tragedy underscores the need for international cooperation in creating comprehensive tsunami detection and warning systems. Deep within the Earth, intense heat melts rock into magma, which rises and escapes through volcanoes, vents in the crust. Volcanoes form at tectonic boundaries, subduction zones, rifts and hotspots. Magma's composition shapes eruptions. Fluid lava creates gentle flows, while sticky magma causes explosive blasts. Volcanoes can build new land or unleash devastating pyroclastic flows, ash and mud, reshaping our world. Throughout history, volcanic eruptions have devastated landscapes and shaped civilizations. From the destruction of Pompeii by Mount Vesuvius to the global climate disruption caused by Tambora and the dramatic eruption of Mount St. Helens, these events reveal the immense power of volcanoes. Monitoring and understanding these fiery mountains is essential for the millions living in their shadow. Landslides are significant disasters, often triggered by earthquakes, volcanic eruptions, or heavy rainfall. They involve the movement of rock, debris, or earth down a slope. This movement can be sudden or slow. Gravity is the primary force driving landslides. Slope stability is a balance between gravity and the strength of the hillside. When this balance is disturbed, the slope can fail. Factors like rainfall, earthquakes, and human activities contribute to instability. Rainfall saturates soil, reducing friction and increasing weight. This transforms solid ground into a fluid-like slurry. Mud flows can travel at high speeds, destroying infrastructure. Earthquakes can dislodge vast sections of a hillside. Human activities like deforestation and construction weaken slopes. These activities create conditions for catastrophic failure. Landslides come in several forms, each with its own dangers. Debris flows are fast-moving slurries of water, soil, and rock. They can easily destroy buildings, bridges, and roads. Rockfalls involve the sudden fall of rocks or boulders. They pose a hazard to roads and infrastructure. Large slides can bury entire towns in minutes. Mountainous, populated regions are particularly at risk. Steep terrain, heavy rains, and seismic activity create hazardous conditions. Expanding populations increase vulnerability. The 2017 Sierra Leone landslide, killing over 1,100 people, highlights the need for better land use planning and risk assessment. Geological disasters are natural, but human actions often turn hazards into catastrophes. Our settlements, deforestation, and construction on unstable land increase risks, sometimes with deadly results. Poor building practices and lack of regulations make earthquakes deadlier. Even activities like fracking can trigger seismic events. As our influence grows, so does our responsibility to respect Earth's delicate balance. Water is the essence of life, carving canyons, nourishing ecosystems, and sustaining us all. Yet, when rivers overflow, this life-giving force becomes one of nature's most destructive hazards. Floods can transform familiar landscapes into dangerous territories within hours, sweeping away vehicles, homes, and crops. Their impact is relentless, destroying infrastructure, livelihoods, and leaving lasting scars on communities. Floods remind us of our dependence on water and our vulnerability to its overwhelming power. Floods come in many forms: riverine, flash, coastal, and those caused by failing infrastructure. River floods rise slowly, covering wide areas, while flash floods strike with little warning and immense force. Coastal floods driven by storm surges and dam failures can be catastrophic. No matter the cause, floods remind us that the boundary between land and water is always temporary. Snow-covered mountains are breathtaking, but they hide a sudden danger: avalanches. An avalanche is a rapid flow of snow down a slope, sometimes moving faster than a train. Up close, they are a destructive force, capable of flattening forests and burying buildings. Avalanches often start when a weak snow layer collapses under new weight, like fresh snow or a skier. Slab avalanches, where a large block of snow breaks away, are especially dangerous. Education, awareness, and proper safety gear are essential for survival in avalanche terrain. Hydrological disasters aren't just natural, they're shaped by our choices. Building on floodplains, urbanizing landscapes, and altering rivers all increase our risk. Impervious surfaces and levees can turn manageable floods into catastrophic events. In mountains, deforestation and development make avalanches and flash floods more likely. Our attempts to control water often disrupt natural systems, making us more vulnerable to disaster. Section 5. Living with the water mitigation and adaptation strategies. Given that floods are the most common natural disaster, and you know that human settlements are intrinsically linked to water sources, learning to coexist with this risk is not optional, it's essential. Fortunately, humanity has developed a wide range of strategies to mitigate the damage and adapt to the threat of hydrological disasters. These strategies can be broadly divided into two categories: hard engineering solutions, which involve building physical structures to control water, and soft engineering solutions, which focus on working with nature and adapting human behavior. A comprehensive approach to flood management often involves a combination of both to create layers of protection. Hard engineering solutions are the most traditional and visible forms of flood defense. These include the construction of dams and reservoirs, which can store vast amounts of floodwater upstream and release it slowly and safely over time. Levees and floodwalls are built along riverbanks and coastlines to act as physical barriers, keeping rising waters out of populated areas. While effective, these solutions are expensive to build and maintain, and as discussed, they can fail catastrophically. They can also have negative environmental impacts, disrupting river ecosystems and sediment flow, which can lead to other problems downstream or along the coast. In recent decades, there's been a growing shift towards softer, more nature-based solutions. These approaches aim to restore the natural functions of the landscape to manage water more effectively. This includes floodplain restoration, which involves removing old levees to allow rivers to reclaim their natural floodplains in designated, unpopulated areas. This slows the river down and reduces the flood risk for cities downstream. Creating wetlands and planting forests helps to absorb rainwater like a natural sponge. In cities, the development of so-called green infrastructure like permeable pavements, green roofs, and rain gardens helps to reduce urban runoff and manage stormwater at its source. Ultimately, the most effective strategies involve foresight, planning, and public awareness. Strict zoning regulations can prevent new construction in the most high-risk floodplains and avalanche paths. Sophisticated forecasting and early warning systems can provide communities with the critical time needed to evacuate and protect property. Public education campaigns can ensure that citizens understand the risks they face and know what to do when a flood or avalanche warning is issued. By combining intelligent engineering with a respect for natural processes and an informed public, we can move from a purely defensive stance against water to a more resilient and sustainable coexistence. Hurricanes, cyclones, and typhoons, different names for the same swirling giants. These massive storms form over warm tropical waters, unleashing powerful winds, torrential rain, and deadly storm surges. Their destructive force can devastate entire regions, as seen in Hurricane Katrina. Preparation and respect for their power are essential wherever these storms strike. Tornadoes are nature's most violent storms. Narrow, spinning columns of air that can unleash winds over 480 kilometers per h. Unlike hurricanes, tornadoes strike with focused fury, obliterating everything in their narrow path while sparing what's just meters away. Born from supercell thunderstorms and wind shear, these atmospheric assassins remind us that the sky's most devastating power can arrive in minutes, leaving behind utter ruin. Heat waves are silent killers, prolonged extreme heat that claims more lives than storms or floods. Vulnerable groups, strained power grids, and urban heat islands all suffer as relentless heat overwhelms bodies, infrastructure, and crops. As climate change intensifies, these invisible disasters are becoming more frequent, deadly, and impossible to ignore. Drought creeps in slowly, draining water supplies, crippling agriculture, and fueling wildfires. Its impacts ripple through food systems, economies, and ecosystems, often unnoticed until crisis hits. As climate change worsens, managing water and building resilience is more urgent than ever. Weather disasters are driven by the sun's energy atmospheric motion and the interplay of heat, pressure, and moisture. Hurricanes, tornadoes, heat waves, and droughts all arise from specific predictable patterns. Understanding these is key to forecasting and survival. Science turns chaos into knowledge, helping us prepare for nature's fiercest events. Satellites, radar, and supercomputers have revolutionized weather prediction, giving us precious time to act. Accurate forecasts and instant alerts save lives if people know how to respond. Technology is our shield, but public awareness and communication are the final vital links in disaster resilience. Some disasters are invisible. Epidemics and pandemics spread silently, disrupting societies and economies worldwide. Our interconnected world accelerates the spread of pathogens, while environmental disruption increases the risk of new diseases. Pandemics remind us that human health and the health of our planet are inseparable. Sometimes the threat from the living world arrives in a buzzing, devouring cloud that darkens the sky. A locust swarm is one of nature's most dramatic and destructive phenomena. Billions of locusts can strip fields bare in hours, destroying crops and livelihoods. For vulnerable regions, a single swarm can mean food shortages, economic loss, and even famine. These living plagues show how one species can become a force of nature with disastrous consequences. Wildfires are a natural force, shaping landscapes for millions of years. In many ecosystems, fire clears undergrowth, returns nutrients, and sparks new growth. But when fires burn out of control, fueled by drought, wind, and human activity, they become disasters, destroying homes, polluting air, and threatening lives. Our actions and climate change now make wildfires more frequent and intense, challenging how we manage our world. Ecosystem collapse is a slow, cascading disaster, an unraveling of the web of life that sustains us. From dying coral reefs to shrinking forests, these changes threaten biodiversity, food security, and even our coastlines. Unlike sudden catastrophes, this crisis is often silent, but its impact on our planet's stability and our future is profound. While biological disasters are driven by living organisms and natural processes, the fingerprints of humanity are, well, all over their increasing frequency and severity. In nearly every case, from pandemics to wildfires, human actions act as a critical catalyst or a powerful amplifier, turning potential threats into global crises. Our relationship with the natural world has become unbalanced, and now the consequences are showing up as biological emergencies. We're no longer just passive victims of these events. We're active participants in creating the conditions that allow them to flourish, which makes our role in both the problem and the potential solution absolutely central. Just consider the link between human activity and the rise of infectious diseases. The relentless expansion of agriculture and urban centers leads to widespread deforestation, pushing us into closer contact with wildlife populations and increasing the opportunities for zoonotic viruses to jump from animals to humans. The global wildlife trade, both legal and illegal, brings diverse species into unnaturally close proximity in crowded markets, creating perfect incubators for pathogens to mutate and spread. And our hyper-connected global travel network ensures that a localized outbreak can become a worldwide pandemic in just a matter of weeks. Our modern way of life has, perhaps inadvertently, engineered a system that's highly efficient at propagating new diseases. When it comes to wildfires, our influence is just as direct. While climate change, driven by burning fossil fuels, creates the hotter, drier conditions that favor fire, human negligence is often the spark that lights the flame. Discarded cigarettes, unattended campfires, and sparks from machinery are responsible for the vast majority of wildfire ignitions. On top of that, our settlement patterns have pushed communities deeper into what's known as the wildland-urban interface. These are areas where human development meets flammable wild vegetation. This WY zone places more lives and property directly in the path of fire, dramatically increasing the disaster potential of a natural process. Even the devastation caused by locusts is influenced by our changing climate. Altered weather patterns, including more extreme and erratic rainfall in desert regions, can create the ideal breeding conditions that trigger locust upsurges. The broader crisis of ecosystem collapse is really almost entirely a human-driven phenomenon, caused by pollution, habitat destruction, overexploitation of resources, and the introduction of invasive species. The conclusion is, honestly, inescapable. Biological disasters are a reflection of our own choices. They're a warning from the planet's living systems that our current path is unsustainable. But this realization isn't a cause for despair. It's actually a powerful call to action to rethink our relationship with nature and build a more harmonious and resilient future. As we look to the future, it is impossible to discuss the risk of natural disasters without addressing the overarching influence of global climate change. This slow-motion, human-driven shift in our planet's climate system is not creating new types of disasters, but it is acting as a powerful threat multiplier, amplifying the intensity and frequency of many of the hazards we have already explored. The fundamental science is straightforward. By releasing greenhouse gases into the atmosphere, we are trapping more of the sun's heat. This added energy is supercharging the Earth's climate system, leading to more extreme and unpredictable weather events across the globe, fundamentally altering the landscape of risk for generations to come. The most direct consequences are seen in meteorological and hydrological disasters. A warmer atmosphere can hold more moisture, which means that when it does rain, the downpours are often heavier and more intense. This directly increases the risk of severe flooding and landslides. Warmer ocean waters provide more fuel for tropical storms, leading to the formation of more powerful hurricanes and cyclones, with higher wind speeds and greater rainfall. At the same time, Shifting weather patterns are making dry regions even drier, leading to more frequent, prolonged and severe droughts and heat waves, which in turn create the perfect conditions for catastrophic wildfires to ignite and spread. The impacts extend beyond the atmosphere. The world's oceans have absorbed the vast majority of this excess heat, causing the water to expand and driving a steady rise in global sea levels. This process is accelerated by the melting of glaciers and ice sheets in the polar regions. Rising sea levels provide a higher starting point for coastal hazards. This means that storm surges from hurricanes push further inland, and normal high tides can now cause regular flooding in low-lying coastal cities. This slow, relentless encroachment of the sea poses an existential threat to island nations and coastal communities worldwide, threatening homes, infrastructure, and freshwater supplies. The interconnected nature of our planet means these changes create cascading effects. A drought in one region can lead to wildfires, which then leave the soil exposed and prone to landslides when the rains finally return. The collapse of a heat-stressed ecosystem like a coral reef diminishes its ability to protect a coastline from a climate-strengthened storm. In this new reality, we can no longer rely solely on historical data to predict future risks. Climate change is pushing us into uncharted territory, forcing us to anticipate and prepare for disasters that may be more powerful and behave differently than anything we have experienced in the past. In our quest to manage future risks, technology presents itself as a powerful yet complex tool. It is a double-edged sword. On one side, technological advancements offer unprecedented opportunities to monitor, predict, and respond to natural disasters, saving countless lives. On the other side, our increasing dependence on fragile, interconnected technological systems creates new vulnerabilities that can be exploited by the very disasters we seek to control. Navigating this duality is one of the central challenges of modern disaster management. Our ability to harness the benefits of technology while mitigating its inherent risks will be crucial for building a safer future. The positive side of the blade is sharp and promising. Satellite technology allows us to track hurricanes from their birth over the ocean. Sophisticated seismic sensors can provide precious seconds of warning before an earthquake's most violent shaking arrives. Supercomputers running complex climate and weather models give us forecasts of increasing accuracy and lead time. Drones can be deployed after a disaster to survey damage, locate survivors, and deliver emergency supplies to inaccessible areas. The rise of social media and mobile technology allows for the rapid dissemination of warnings and the crowdsourcing of real-time information from disaster zones, empowering both citizens and responders. However, the other edge of the sword is equally sharp. Our modern society is built upon a delicate web of technology, including power grids, communication networks, and global supply chains. These systems, while efficient, are also brittle. A single major event, like a powerful solar flare or a catastrophic hurricane, could knock out power and communications over a vast area, instantly crippling our ability to respond. The failure of these systems can turn a manageable emergency into a complete societal breakdown. Our reliance on just-in-time logistics means that a flood in one country can lead to empty store shelves a continent away, highlighting our global interconnectedness and systemic fragility. The challenge, therefore, is not simply to develop more technology, but to develop more resilient technology. This means building decentralized power grids that are less prone to large-scale failure. It means creating redundant communication systems that can function when primary networks go down. It involves using technology to create smarter, more adaptable infrastructure that can withstand environmental stresses. As we move forward, we must approach technological solutions with a critical eye, ensuring that in our effort to solve one problem, we do not inadvertently create a new and potentially more dangerous vulnerability for the future. While we cannot prevent earthquakes from shaking or hurricanes from forming, we have significant power to reduce their impact. The most effective defense against the fury of nature is not built of concrete or steel, but of knowledge, planning, and collective action. This is the essence of building a culture of resilience, a societal mindset that shifts the focus from simply reacting to disasters after they strike to proactively preparing for them long before they happen. This involves every level of society, from individual households learning how to protect themselves to communities and governments implementing policies that reduce underlying vulnerabilities and enhance their capacity to bounce back after a crisis. At the individual and family level, preparedness is the foundation of resilience. This begins with education, understanding the specific risks present in your region and learning the appropriate safety measures for each. It means creating a family emergency plan so everyone knows where to go and how to contact each other if separated. It involves assembling an emergency kit with essential supplies like water, food, a first aid kit, and a flashlight, allowing a household to be self-sufficient for several days if services are disrupted. These simple, proactive steps can dramatically reduce fear and chaos during an emergency and can be the difference between life and death. At the community level, resilience is built through cooperation and smart planning. This includes establishing and regularly testing early warning systems to ensure they reach all residents, including the most vulnerable. It involves enforcing strong building codes that require structures to be resistant to earthquakes or high winds. Smart land use planning that prevents critical infrastructure and new homes from being built in high-risk areas like floodplains or coastal zones is paramount. Communities that invest in public education, conduct regular emergency drills, and foster strong social networks where neighbors help neighbors are invariably better able to withstand and recover from a disaster. Ultimately, building a culture of resilience requires a fundamental shift in perspective. It means viewing disaster preparedness not as a one-time expense, but as an ongoing investment in the long-term safety and security of our communities. It requires moving beyond a fatalistic view that disasters are unavoidable tragedies and embracing the empowering idea that while hazards are a fact of life, the scale of the disaster is a matter of choice. By embedding preparedness into our daily lives, our community planning, and our government policies, we can face future risks not with fear, but with the quiet confidence that comes from being ready. The story of natural disasters is, in the end, the story of humanity's relationship with its home. We have explored the immense power of the Earth, from its restless geology to its turbulent atmosphere. We have seen how these natural forces intersect with our societies, and how our own actions can either amplify the danger or enhance our safety. As we stand at this critical juncture in the 21st century, facing the compounding pressures of a growing population and a changing climate, the path forward demands a renewed sense of shared responsibility for the well-being of our planet and for each other. The challenges are global in scale, and they require global cooperation. This shared responsibility must begin with a commitment to addressing the root causes of our increasing vulnerability. This means taking decisive, collective action on climate change by transitioning to cleaner energy sources and reducing greenhouse gas emissions. It is no longer enough to simply build higher seawalls. We must also work to slow the rate at which the seas are rising. It means prioritizing the protection and restoration of natural ecosystems, like forests, wetlands, and coral reefs, which are not just bastions of biodiversity, but also our first and most effective line of defense against floods, storms, and landslides. Our environmental health and our disaster risk are inextricably linked. Furthermore, we must recognize that vulnerability is not distributed equally. It is often the poorest and most marginalized communities, those who have contributed the least to problems like climate change, who suffer the most from its consequences. A just and effective approach to disaster risk reduction must therefore include supporting these communities. This involves the transfer of resources, technology, and knowledge from wealthier nations to help developing countries build more resilient infrastructure, establish early warning systems, and adapt to the inevitable changes that are already underway. In our interconnected world, a disaster in one region can have ripple effects across the globe. Helping others helps ourselves. The journey through Earth's fury teaches us a lesson of profound humility and urgent hope. It reminds us that we are part of a dynamic and powerful natural system that we do not control. But it also shows us that we are not helpless. Through scientific understanding, technological innovation, thoughtful preparation, and global cooperation, we have the ability to forge a safer and more sustainable future. The challenge is great, but our capacity for ingenuity and compassion is greater. The future of our relationship with this beautiful, formidable planet is, ultimately, in our hands.